So my name's Josh. I'm a developer on the CXSS team here at REA. I'm a craft beer enthusiast and I'm a GraphQL evangelist. Evangelist is a pretty strong word, but I do just really like GraphQL, and that's why I'm here. So just to show of hands, who's used GraphQL, like built something with GraphQL before? Okay, cool, so it's like half. Awesome. So I want to cover a few key things today. The first thing is the basic concepts. So what is GraphQL? What makes up GraphQL? I also want to talk about how we're using it in CXSS and some of the benefits that we've seen in implementing it. So what is GraphQL? GraphQL was created by Facebook, and they started back in 2012 when they were trying to rebuild their native mobile applications. So at the time, their native apps were basically just wrappers around web views. And so they didn't have a good way to query for newsfeed data. And so they basically invented a query language for your API. And it's also a runtime for fulfilling those queries. So what does that mean? Let's look at an example. So here we have a pretty basic example. We've got an album, and an album has an artist. And an artist can have many band members. So super simple diagram here. Let's translate this into GraphQL. So it all begins with the schema in GraphQL. And a schema is the description of your data. The syntax that you see here is the GraphQL schema definition language. This is a standard. And everything in the schema is made up of types. So types can have fields that can be primitive values such as strings or integers, or they can be other complex types. So in our example here, we have three types. The album, which has name and release, which are just primitive values. But it also has an artist, which is another complex type that we've defined. And an artist has a name and some members. And the square brackets that you see here around band member denotes an array. The bang or the exclamation mark means non-nullable. So this band member array is actually a non-nullable array with non-nullable items in it. And then we have a band member, which is just a string and a date. So now we have a way to explain our model in GraphQL. Let's look at how we can query it. So queries are the access point to our data. And there's two parts to queries. On the left-hand side, we have a query definition. So that makes up part of our schema. It defines it's the definitions in our API that describes the possible queries that a client can make to a GraphQL server. So it's essentially our public interface to our GraphQL server. It's also our documentation. Since GraphQL is introspectable, you can get documentation from this. And also it can have arguments. So you see in this example we have from, to, and search. And it returns a type. So here we're returning an array of albums. On the right-hand side is an example of a client query. So this is an example of what a client might ask for from our GraphQL server. So they begin with the albums query that we've defined, and they give some parameters from 2000 to 2006. They're asking for name and released, and because albums have artists, they can also ask for the artist data. So they're asking for the name of the artist, and because artists have members, they can also ask for names of members. So you can see how this query actually encapsulates our entire data model. It covers our entire schema in a single query. So I've been talking about queries so far, and queries are really like the R in the CRUD of GraphQL, if you will. But the rest of the CRUD is made up of mutations. So there's a thing called mutations. I won't really go into any more detail about mutations, but you can think of them as queries with side effects. So they operate exactly the same as queries. They have arguments, they have a return type, but something happens behind the scenes. Something gets created or saved or updated or whatever. So let's go back to our client example. We have this query on the left, and on the right-hand side you can see is an example response. So this is just JSON data, but you can see how our response almost looks like a hydrated version of our query. So all of the fields that are requested in the client client query match one-to-one to the JSON payload. So we've seen how clients can ask for data through the queries that we've defined, but how does GraphQL actually fetch this data behind the scenes? So that's where resolvers come in. Resolvers are the mechanism in which to fetch the data required to fulfill a query. They're responsible for fetching the data and transforming it to match our schema. Every field in GraphQL has a corresponding resolver function. So with our albums query, we're just fetching some data from an API, the albums API. And you can imagine that this API probably returns an array of objects, and each object is an album type, right? If you look at the bottom example, this is our set of album resolvers, and each type has a function, and that function takes an argument, which is the raw album object, if you will, from the albums API. So we get the raw values, which have, in the first two examples, album name and year released. And since we've decided to call them name and released in our schema, we're just essentially renaming those fields to match our schema. The last example, artist, is a little bit special. So here we can imagine our album object, that raw object, has something called an artist ID. And that's our link to the artist that corresponds to that album. So in this resolver, we're going and fetching the artist from a different API using that ID. It's really important to note that in GraphQL, the resolvers are only executed if the client asks for it. So if a query is requesting that particular field, that's when a resolver will get called. If the client doesn't request that field, it doesn't get called. So in our example, if you queried for albums but not for any artist information, we'd save that round trip to go and fetch artist data. So data can come from anywhere, really. It can be a database, it could be an S3 bucket, it could be a local file, it could be some other cloud service. It doesn't matter where our data comes from. Our resolvers know, we define our resolvers to know where to get that data from and pull it all into one place. So I want to touch on a little bit about the backend for front-end concept, which is pretty popular at REA. This data orchestration, getting data from different sources, is a pretty common concept for the BFF. So typically it orchestrates data from multiple sources and exposes it via multiple endpoints. And each endpoint is typically associated with a particular application view. When you have a mobile app and a web app, they usually have different data requirements. Mobile app's usually a slimmed down version. Maybe it needs some different fields to the web equivalent. And this means that you start going down the route of having a BFF for your web app and a BFF for your mobile app. And these will probably be maintained by different teams, the web team and the app team. And this was kind of the approach that we were thinking about when we started designing the system architecture for CXSS. Until GraphQL. So CXSS is a customer platform that spans many lines of business. We have a lot of data sources and data dependencies. Because of this, we felt that it was a perfect fit for GraphQL. We structure, instead of having two BFFs, we just have a single GraphQL gateway. We structure our GraphQL schema in a way that supports both web and app client data needs. And now we have a single point of entry for all of our clients. We build and maintain this code base as a collective team instead of being siloed by our architecture. And because we have one API, all of the technical implementation details, like how we fetch data, authentication, error handling, caching, all of these things are in one place. It also provides a really consistent experience across both web and app, and it sort of minimizes some of the issues you would have in having two different BFFs, like inconsistent copy, different error messages, that kind of thing. So GraphQL is very client-driven. It sort of flips the model on its head. Instead of the API pushing data to clients, the power is on the clients to request what data it needs to fulfill their application views. So instead of the client orchestrating a bunch of endpoints and data together and knowing how to join all these things, they just make a query to GraphQL and GraphQL figures out the rest. There's no over or under fetching, so only the fields that the client asks for is what it gets returned. And this is particularly impactful for mobile devices which have data constraints. It allows for really rapid iteration on the front end. So the client doesn't need to wait for changes for the back end. If they need an extra point of data in their view, they can just request it in the query and get it straight away. Okay, so evolution over versioning. New additions are pretty easy to GraphQL. The client can only request what it knows about. So adding a new type or a new field is pretty trivial without breaking clients. It also encourages an evolving API design. So when a field needs to be replaced by some new field, for example, you can add that alongside the old field, deprecate the old field, and then when clients are no longer requesting that old field, you can remove it. In fact, Facebook's GraphQL implementation still supports version 1 of their mobile app from 2012 because of this, and which is pretty crazy. So it also allows for really fine-grained insights. So because all fields have resolvers, which are only executed when a query asks for that field, it allows for a really fine level of detail around what queries are asking for what fields, how often and what, and this really helps to inform the evolution of the API design. Everything is pinned on the schema with GraphQL, so it's all about the schema. It's kind of the view of your data model. The way that we define the schema is driven by the needs of the clients that consume it. And we define those relationships between our types so the clients don't have to. It's strongly typed, so there's a well-defined contract between front end and the back end. So this means that front end and back end can be developed in parallel with confidence. And this is really important, especially for our team at CXSS, because we have data dependencies with other teams, and we either need them to do some work to uplift that API, or we need to do some work for that API. There's a lot of moving parts. We just mock that data because we have a well-defined schema, we have that contract, and we have the confidence for our UI developers to go and build those views with the confidence that when we plug in those integrations, it'll just work. And it helps us think about our data as a connected graph. So with a traditional REST API, you have multiple endpoints or resource URLs, and you have to know where to go to different endpoints to join them together. Clients can just think about data as a payload of connected objects that satisfy a particular view. Okay, so the not so good things about GraphQL, caching is one, because GraphQL typically lives on a single HTTP endpoint. It loses some of the benefits of those standard HTTP caching out of the box. So that's something that needs to be self-rolled. Performance monitoring and profiling Because GraphQL fires multiple resolvers that fetch from a lot of different data sources in one query, and the possible combination of that is kind of up to the client. Monitoring those resolvers for performance requires more custom work. Tooling is another one. GraphQL's only been open source since 2015. It's gaining a lot of traction in the industry, but it's fairly fresh as a technology. So there are some tools starting to emerge, like Apollo Engine, that does caching and performance monitoring out of the box, but they're still pretty early days. Some of those more established services like New Relic don't yet support GraphQL. Okay, so you're probably thinking at this stage, like, GraphQL is awesome, I'm just going to build everything from now on in GraphQL. Why would you ever write a REST API again? It's not one or the other. Like, they're not mutually exclusive. GraphQL, I think, is really powerful as a data orchestration layer. So in our case, in CXSS, our application has a lot of data needs, and we need to get that from a lot of different places. And because it's focused on the client, it suits our use case well. REST APIs, I think, are useful for like single-purpose public APIs that have little to no other downstream data dependencies. They also have really well-established standards around caching and error codes and that kind of thing. GraphQL is not tied to a particular language. It's a specification. So there are serverless implementations in most major languages. We're using JavaScript, in particular Apollo Server, but you can take your pick out of pretty much any language. So hopefully you've got a pretty good understanding of the basics of GraphQL, the benefits of it, and how we're using it to power our platform in CXSS. If you want to know more, graphql.org is a great place to go to learn the basics. It's the official documentation. It covers a lot more than I've talked about in this talk. And when you're ready to start building something, howtographql.com is great for tutorials in different language stacks. So you can just get up and running quickly and build something. Or if you just see me around the office and you want to talk about GraphQL, I'm always happy to answer questions and have a chat. Thanks very much.
Question?
Have you done any benchmarking on performance and scalability compared to traditional RDBMSs?
That's a good question. It really depends on your architecture and how many like data sources you have. We haven't. I guess the bottleneck is like at your resolver level. So when you're fetching data, that's kind of like the place to do performance monitoring. We haven't done it yet, but I know that there are some other teams in REA that have done that. And yeah, it's certainly a useful thing to do. I'm not sure if that answers your question, but.
So basically, you have to, like the front end have to wait for like all the resolver to finish and then get the data. So in like traditional like REST way, you have like some component already render some data if it's response fast, and some of them maybe like slow request is still like showing a spinner. But that is a benefit because you can like at least show a partial page. And in GraphQL case, like you have to wait for maybe long time because the slowest one is like the bottleneck. So yeah. How do you solve that problem?
Yeah, it's a really good question. There's kind of two ways to do this. One, the current way that it's done is that you can split your queries up. So you can request like, you know, basically have different components that fire different queries at the same time. And the other way to do it is there's a new spec in GraphQL called defer, and you can mark part of your query. So like you have a big massive query, there's some things that you might want to get straight up, and there's some things you want to wait for. You can chuck a defer tag on there, and it'll come back in parts. So it sort of like streams back, if you will. And like there's client frameworks that handle that streaming for you.
So you've got this obviously runs a lot of the logic and the decomposition of the. Does it decompose the model at the client and request the different URLs from the client, or is it decomposed on the server side? So it just makes one call to the server and then those sub requests are fired off on the server side?
Yeah, that's right. Yeah. So you have
Yeah, I was just going to say, if there's considerable logic running at the client, could you use this in a B2B API sense where there's not a browser running a client library? Could you use this API sort of thing just for data?
Yeah, are you talking about like GraphQL to GraphQL talk, or like GraphQL to another REST API, or?
Well, yeah, how would you use it without a browser context, I suppose?
Yeah, so I mean, GraphQL is like, it's sort of transport layer agnostic, and it's like, it doesn't have to be client to GraphQL server. Like another server can fire off all it is like, you put your GraphQL endpoint on a typical, HTTP endpoint, and you can just fire a post request at it with a query string. So like
Yeah, right. So it's
API
just a GraphQL payload that goes.
Yeah, exactly.
Yeah, cool.
Yeah. Good catch.
So just on the question of tooling, you mentioned the tooling's not quite there, but I'm interested to know how much is there. Do you know how many queries you're serving per second or something?
Yeah.
What fields that have been deprecated are no longer being used and could be deleted, that sort of stuff?
Yeah, so in CXSS, we're pretty new, so we haven't set that up yet, that profiling. I know that there is ways to do it to instrument through like New Relic, for example, and capture that data. It basically comes down to like profiling your resolvers, and also capturing like what queries come through. I mentioned Apollo Engine, which is basically it's quite similar to New Relic, but for GraphQL. So it keeps track of like how many queries are coming in, of the same query, what fields are being called, what's the performance of your resolvers. It handles caching for you, like kind of all out of the box solution. So there are things out there that enable you to do it.
Time for one more question.
So you mentioned we might need like a REST API as well as a GraphQL. Can you use the one schema to generate both APIs?
I believe there's tools out there that do that. You can define a schema and then it'll like spit out endpoints for you. I haven't really explored them, but yeah.
All right, so it might come as tooling develops.
Yeah.